When we are subtracting and adding fractions or polynomial expressions, we have to remember that we have to have a common denominator in order to add them. So if you have a common denominator, you just go ahead and add the two numerators and keep the denominator, okay? When we do not have a common denominator, we have to get one. And we do that by multiplying each side by the denominator of the other one. So again, when we are adding with a common denominator, the first step is to add the numerators and keep the denominator, that common denominator. Then we will look to see if we can simplify. And as we should remember from our first lesson, that will probably involve some factoring. Okay, so looking at my first example, I will see that I have a common denominator, 3x squared and 3x squared, and we're adding those. So I keep my common denominator, 3x squared and 3x squared, and then I add the 2 plus 1. 2 plus 1 is 3. Now, can I simplify anything? I sure can. 3 divided by 3 is 1. So my solution, my answer is 1 over x squared. If I look at my next example, I will see that I have a common denominator again of x squared plus 1. So I will keep the x squared plus 1. And then I will add the 2x squared plus 2. Okay, so can I simplify anything? In order to do that, I will need to factor here because both of these terms have a common factor of 2. So I have a GCF of 2 that I'll factor out, and that leaves me with an x squared here plus a 1 here. In the denominator, remember, if this were a subtraction symbol right here, I would be able to factor this as a difference of 2 squares. But this is addition, so I just have to leave it like it is. And when I do that, I will see that I actually have a common factor. So the x squared plus 1 divided by x squared plus 1 is 1, and that leaves me with my answer of 2. So subtracting with a common denominator is the same, but we do have to be careful with the subtraction symbol. Sometimes that might require us to use like a distribution or something. So that's the first step I always tell students to do. We want to distribute the minus sign to the second expression. Then the second step would be to subtract the numerators. And keep the denominators just like before. And lastly, simplify if needed. Okay, so once again, I have 12x and 12x, so I have that common denominator. So all I have to do is subtract 7 minus 5. 7 minus 5 is 2. Now can I simplify? And I can. This is like reduce. So 2 divides into 2 once, 2 divides into 12 6 times. So my answer is 1 over 6x. Then my second example, I have 4x, or my common denominator of 2x minus 1. And then I have to subtract my numerator. So I have 4x squared minus 1. And hopefully you will notice that this is a difference of two perfect squares. So the square root of 4x squared is 2x. The square root of 1 is 1. Oops. So when I factor that, I get my two binomials, addition and subtraction. Like I said, the square root of 4x squared is 2x. The square root of 1 is 1. And in my denominator, I have 2x minus 1. So 2x minus 1 divided by 2x minus 1 gives me 2x plus 1 as my solution. All right, so we're going to go from adding and subtracting with a common denominator to adding and subtracting with distinct denominators. All right, so the first thing to do when we have distinct denominators is we do need to factor the denominators. It will not do you any good to factor the numerators because when we have to add or subtract, we would have to multiply them back together. So only the denominators need to be factored first. Then we need to find the common denominator from that. Then we will add our numerators. And keep that common denominator just like above. And then again, check to see if we need to simplify. So to factor my denominators, I'm going to take a peek. 3x squared is just a little monomial, so there's not really anything that I need to do there. But here I can see that I have a common factor of 3x. Okay, and when I factor that out, I have 3x minus 4 left in my monomial or my denominator. So if I take a look, I will see that I have 3x squared, and this is kind of like a 3x squared, but I need to add the 3x minus 4 or multiply by the 3x minus 4 to make these the same. This is missing the 3x minus 4. And then if I have 3x squared times 3x minus 4, this is missing an x. So if I multiply by these, I will end up with a common denominator. So let's take a look over here. If I multiply the denominator and the numerator by x here, the denominator and the numerator by 3x minus 4, this is what I'm going to get. 1 times 3x minus 4 is 3x minus 4. 3x squared times 3x minus 4, I'm just going to leave that. I don't need to multiply that out. Plus, x times x is x squared. And then again, in this denominator, I have 3x squared times 3x minus 4. Okay, I have a common denominator now, which means that I can add these together. So I keep the denominator. And now I'm going to add my numerators. So if I look at this, I see 3x minus 4 plus x squared. I'm going to write it in standard form, though. And then notice that this is a trinomial that I can factor probably. So a times c is negative 4. Factors of 4 are 1 and 4, 2 and 2. I need a negative 4, so something's got to be negative, and to give me a 3, negative 1 plus 4 gives me a positive 3. So using my little shortcut, I know that's going to be x minus 1 times x plus 4. And then here is my denominator. So what can I simplify? I have an x minus 1, but I don't have one in my denominator. I have an x plus 4, but I don't have one of those in my denominator. So I actually cannot simplify, and this is my result from adding the two polynomial expressions, rational expressions. All right, looking at my second example. I have x squared minus x minus 12, and because the joys of video, I am going to just write the factored form there, which is x minus 4 times x plus 3. And here I can factor my denominator here by 12 times, it's going to be 12 times x minus 4. And then I'm going to look and see. So I have an x minus 4 here and an x minus 4 here, but I'm missing a 12, so I need to multiply the numerator and the denominator by 12. And then over here, I'm missing an x plus 3, so I need to multiply the numerator and the denominator by x plus 3. So what am I going to get? 12x plus 5x plus 3 is 15. And that's all over my common denominator, 12 times x minus 4 times x plus 3. Now, looking at my numerator, I can see that there is more to do here. So I have 12x plus 5x, that's 17x plus 15, all over my common denominator. So can I factor anything in my numerator? No, this is a prime number. There's nothing I can factor, which means there's nothing in common to divide out. So this is my answer to my second example. All right, so let's subtract some. The steps are pretty much the same, except for I must remember to distribute the minus sign to the second expression. Then I need to factor the denominators and get a common denominator. Find the common denominator. And number 4, let's see, I'm going to combine the like terms. Of the numerator, or add them, whatever you want, subtract them, whatever you want to call it. And then simplify if needed. All right. So for this one, to find a common denominator, I'm actually just going to have to multiply the top and bottom by 7 and the top and bottom by 4x. The distribute the minus sign, I skipped because it's just minus 1. So there's really no distribution. So 7 times 3 is 21. Divided by 4 times 7 is 28x. Minus 1 times 4x is 4x. Divided by 28x. So I have 21 minus 4x. And that is divided by the 28x. And I do not, like 4 and 28 would reduce, but the 21 does not. So it has to be all three, which means that this is my answer. Okay, last example. Factoring my denominator, I have 2 times x minus 1. factoring this denominator, I have, because I'm fast forwarding through my video, x minus 3 times x minus 1. Okay. And I also need to remember that I have to distribute. So here's where it really makes a difference. I am subtracting a negative 2x, which is plus 2x, and I am subtracting a negative 1, which is plus 1. Okay? So here are my numerators. And now I need to find my common denominator. So they both have an x minus 1, which means this one over here needs an x minus 3. And this one over here needs a 2. Okay? So my common denominator is 2 times x minus 1 times x minus 3. And the x plus 2 needs to be multiplied by the x minus 3, and I already wrote my 2 over here. Okay, so let's remember how to multiply these. I have x times x, here, another color. I have x times x, which is x squared, x times minus 3, which is minus 3x, 2 times x is 2x, and 2 times negative 3 is negative 6. When I combine my like terms, I get x squared minus x minus 6. So that is my new numerator. All right, so it's x squared minus x minus 6 plus 2 times 2x is 4x, 2 times 1 is 2, and it's all over my common denominator. We do not want to multiply that back together. Oops. Because then we'd have to factor again to simplify. All right, let's collect our like terms here. So I have x squared. Negative x plus 4x is a positive 3x. Negative 6 plus 2 is a negative 4. And all of that is divided by 2 times x minus 1 times x minus 3. So now I need to see if I can simplify. So can I factor x squared plus 3x minus 4? And the answer is yes, I can. So when I factor that, I get x plus 4 times x minus 1. And all of that is over my common denominator. And then I see that I have a common factor that will divide out. So what is my solution? My numerator is x plus 4. My denominator is 2 times x minus 3.